Hi there, welcome to my YouTube channel. My name is Darlington Nkwazi. In this video, I'm going to show you how to create contour graphs and embed them in your PyQt5 applications. Now, this is a follow-up to a video that I created earlier on how to embed Matplotlib graphs in your PyQt5 applications and show them with Q combo box. And I got a comment from one of my viewers, that's Julian Dugut, and he says, "Nice video. I would like to ask if a plot.contour graph can be integrated with your UI instead of a bar graph." Alright, I think this video would answer Julian's question, so let's quickly dive into it. So I'm going to create a folder here and I'm going to call it subscriber. So this is where I'm going to save the UI file and the Python file. Alright, so now go to Qt Designer. Okay, and create a main window. Then I'll come here and reduce the size because I want it to be smaller. Okay, I'm going to remove the menu bar and add a frame to this. Let's just add two. Okay, so one for the graph and one for the button. Okay, so now we'll lay them out vertically. Okay, so this one at the top is where the graph would be displayed, and this here is where I'm going to put the button. So let's quickly add the button. Supposed to be at the top. Okay, so then I'm going to lay this out horizontally. Okay, and set the alignment of this frame to bottom, and I'm going to change the vertical policy here. I'm going to change this to expanding so it stretches out. Okay, we could change the text here to click here to view contour graph. Alright, we could style it if you want. Not sure that is necessary, but let's just reduce this spacing here. So I'll come down here and reduce the margin. Okay, so with this I think we're done with the UI, so I'll just save it on my desktop, okay, in the folder that I created, and call this contour graph. Okay, so I'll save it there. What I'm going to do next is open Qt Designer. What I'm going to do next is open Visual Studio Code. Okay, and head straight to the folder on my desktop. That's the subscriber folder. I'll click that, and now we can see our UI here. Okay, our UI file, and this is what it looks like. So what I'm going to do now is head to terminal and open a new terminal. Then as usual I'll convert this to a Python file. Okay, so now we have our Python file. Okay, let me just run it. Okay, so it works. This is what it looks like. Okay, so this is where I'm going to put the graph or the canvas. that would show the graph rather. Okay, so what I'm going to do next is import the necessary modules. So I'll say import matplotlib.pyplot as plt, and then I'm going to say from matplotlib dot backends dot backend underscore Qt5 arg. Okay, import figure canvas Qt arg as figure canvas. All right, we're going to need numpy, so I'll just say import numpy as np. Okay, so now we have imported the necessary modules, so yeah, modules and libraries. So I'll so let's go back to Qt Designer. So this frame here, this frame here is this frame, okay, and the name is frame, okay, and then this frame 2 here is this other frame that is housing this push button, okay, and the push button itself is called push button here. All right, so we'll go back to Visual Studio, and so this is the first frame, okay, and this is the second frame. All right, so come to this first frame. This is the frame where we want to put the canvas. All right, so we'll come here and say create horizontal layout. We are giving it a layout so that it fits nicely into the frame. Okay, so we'll create a horizontal layout first. You can give it a vertical layout if you want, but I'm using a horizontal layout. All right, so we'll say solve.horizontal layout, and you have to be sure that it doesn't have any attributes that has the same name. Okay, so you want to make sure that this name is unique. All right, so I'm calling it horizontal layout new. All right, and I'm going to say equal to Qt widgets dot qhbox layout solve dot frame. Okay, and then I'm going to say solve dot horizontal layout new here dot set object name as horizontal layout new. All right, so now I'm going to put the canvas. So I'll say solve.figure, okay, equal to plt.figure, and then I'm going to say solve.canvas is equal to figure canvas, okay, and then solve.figure. Okay, so let's just say end of canvas. All right, and now we're going to say solve not horizontal layout new dot add widget and say solve dot canvas. Right, then we can say end of horizontal layout. All right, so we're done with that. We could run this. We'll save it and run it and see what it looks like. Okay, it says attribute error, function object has no attributes, set underscore canvas. I think there's something wrong here. Oh, sorry, this is supposed to be self.frame. Sorry about that. So it's supposed to be self.frame. Okay. So we'll save that again and run it. It's just saying the same thing. Still saying the same thing. Okay, let me check. Self.figure equal to PLT. Okay, yeah, it's supposed to be, yeah, brackets here. Okay, so I'll save that again and run it. Okay, so now it shows. Okay, so but it still doesn't show our canvas. Okay, so I'll go back. There's another thing that is wrong here. So this is self.figure equal to PLT figure. Okay, and self.canvas equal to figure canvas self.figure. All right, and self.horizontal layout new dot add widget. Oh yeah, correct, this is supposed to be self.canvas. I don't know why I changed it initially, but this is supposed to be self.canvas. So I'll run it again and now it shows, thank God. All right, so this is where the canvas, this is where the graph would be displayed. Okay, so we have our canvas neatly on the frame. Okay, so we'll cancel that and now head down to the push button. See, so this is where the push button is. Okay, this is the push button. All right, so I'm going to come here. It's in frame 2, so I'm going to say clicked equal to lambda. Okay, and say what I'm going to call it, let's say self.contour graph. Okay, and then I'll take this now and define this method. Okay, so I'll come down here, I copied that already, so I would say contour graph and type self here. Okay, so now we're going to create the contour graph. All right, first we're going to say clear canvas, and then we say self.figure.clear. Okay, that's to clear the canvas. Okay, and then we're going to say self.figure dot add subplot 111. Okay, and what we're going to do next is create the contour graph. So on the x-axis I want 10 evenly spaced numbers. Okay, I want them to start at -5 and stop at 5. Okay, so I'm going to use line space. okay, and I'm going to say minus 5, 5, and 10. Okay, so what this means basically is I want 10 evenly spaced numbers, which is this 10 here, and then I want them to start at minus 5 and stop at 5 inclusive. So we're saying 10 evenly spaced values, okay, start at minus 5 and stop at 5. Okay, I will do the same thing for y. Okay, so I'm going to copy this and paste it here, and I'm going to change this to y. All right, and then I'm going to say let's just see what they look like. So I'll say print x. Okay, so if I save this and run it and click this button here, it shows the values here at the bottom. Okay, so you can see there are like 10 values here. It's an array. Okay, so you have minus 5, minus 3.88, minus 2.78 approximately, minus 1.67 approximately, then minus 0.56 approximately again. We have the same value here. We have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 values there. All right, it's the same thing for y, so there's no need to print that out. Okay, let's just do it. Okay, so print y. Okay, let's comment x out and save this and run it again. Okay, so I'll click this button now. We'll see the values for y. You see they're the same with that of x. Okay, so we'll cancel that now and we'll comment this out. All right. Okay, so what we're going to do next is mesh x and y, okay, to form a two-dimensional array of x and y. All right, so what we're going to do is say x, y. This time let's use capital letters and say np equal to, np dot mesh grid, and say x, y. All right, and then so let me just put a comment here. So this returns a 2D array. Okay, so what we're going to do next is say want to describe f of x and y. All right, we'll call that z. Okay, so we'll say z is equal to x squared plus y squared. Okay, and then we'll come down and say plt.contour x, y, and z. Okay, and levels equal to 50. Then cmap, that's the color map, or color mapping if you like, is col1. Okay, and then save it. And then we can say self dot canvas dot draw. Okay, we'll save it again and see if it works. Okay, now we have the contour. Okay, but this time it's 2D. Okay, so you can see it. It's clear, very clear. All right, so this is what it looks like. So we'll cancel that and let's see what we can add to this. We can give this a 3D projection. Okay, so we can come here and say projection equal to 3D. Okay, we'll save that and run it again. Okay, when we click this is what we see. Okay, so this is what it looks like. Okay, it looks beautiful actually. So we'll cancel that. Let's see what else we can do with this. Okay, we can add labels to this. We can say can come down here and say let's put a color map first. Let's say PLT yeah, not contour this time, color map, I mean color bar rather. Sorry, I wanted to say color bar, so color bar. So save that and run it again, see if that works. Oh, it doesn't. Sorry, I didn't spell it correctly. So color bar, take note of that. So I'll save it now and run it again. So if I click this, you can see a color bar here. Okay, so cancel that and let's see what else we can add to this. We can add labels. So you can say plt.x label. Okay, and say x-axis, and then we can say plt.y label y-axis. Okay, if I say plt.z label, it's not going to work, but let's just try it. Let's see. Okay, so if I click this, it doesn't work, and the reason is because of this plt.z label here. I'm going to save it and run it again, so you see what I'm talking about. I've commented this out. Okay, so I'll run it again. So if I click this, it shows, and it clearly shows the x-axis and the y-axis, but it doesn't show the z-axis. Okay, and that's because PyPlot does not have any support for z label. Okay, okay, so what we could do is, there's a way we can go about this. I'll just comment this out, and then I'm going to come up here and say ax is equal to self.figure.add subplot 111 projection equal to 3D, and then I'll come here and say ax dot set x label x-axis. Okay, then I'll copy this and paste it here. Then I'll change this to y label and y-axis. Then I'll come down here again and change this to z label and z-axis, and then I'm going to save it and run it again. And when I do that, it works. Okay, so now you can see, oh wait, it doesn't work. It doesn't work. Oh, it works. Actually, it works. Yeah, I think it was covered by the color map. That was why I didn't see it initially. If I increase the window size properly, I would see it. Okay, Okay, so this is it here. All right, so x-axis, y-axis, and z-axis. Okay, so it works perfectly. So that's how to go about that. I have another way of doing this. Okay, what I intend to do is do a series on PyQt5. Okay, if you want me to do that, please let me know in the comments box. If you want me to go ahead, I have that in my plans actually. But in the meantime, if you have a more efficient method, please let me know in the comments box. If you enjoyed watching this video, please subscribe to my YouTube channel, like, comment, because that helps with the YouTube algorithm. Also hit the notification bell, and I'll see you in the next video.